We've come to the end of another skill. That means it's time to review what we've learned by taking a quiz. First up, out of 5 questions, what two networking constructs are separated by Lisp? Well, it's right there in the name. Location and identity separation protocol. We are separating the identity of a device from its location. In a traditional network, the ID, the IP address is really what that comes down to, is bound to a specific subnet, which is bound to a specific location, because we can't split up that subnet among different places. Well, in Lisp, we can take a single subnet and split it up and put part of the subnet here and part of the subnet here and part of the subnet here, so that your identity, your IP address, now is no longer bound to your location. This allows me to keep my IP address, my ID, as I move from location to location. Lisp is part of the magic that makes software-defined access fabrics work. And speaking of magic that makes SDA work, on to question number 2. What feature does VXLAN have that Lisp does not at the data plane? Lisp has 2 components. It has a control plane component, and we still leverage this in SDA. However, the data plane, in other words, the tunnel mechanism, this doesn't work for us in SDA because it lacks the layer 2 feature set that we need. Now, VXLAN provides that, but it doesn't just provide layer 2, it also provides layer 3. Because we do have other layer 2 mechanisms out there that we could have borrowed, but VXLAN gives us both. The ability to transmit the original Ethernet frame, that's the layer 2, and the ability to segment via VRFs at layer 3. Question number 3. What parameters within a VXLAN header carry information about how to segment the network traffic? Well, we have 2 different ways to segment a network. We have macro segmentation and micro segmentation. Macro segmentation is largely for service providers and multi-tenant environments. It's saying that we have multiple disparate networks that need separation from each other. On the other hand, micro segmentation is saying we have one network, but we need segmentation within that single network. Well, we have 2 different concepts and 2 different sets of tags that we use for this concept within the VXLAN header. We have the virtual networks that help us at the macro segmentation level, and we have scalable groups at the micro segmentation level. Now, from a tagging perspective, VXLAN carries the virtual network information in that VNID, the virtual network identifier. And then because Cisco expanded on the VXLAN spec to call it VXLAN GPO or group policy option, we can now carry the scalable group tag or SGT within the header as well. Next up, what are the 2 types of tunnels that an access point builds in an SDA fabric solution? Well, if we remember our network where we have the fabric here in the middle, and then we have a switch attached to that fabric, we have the control plane node over here, and we have a wireless LAN controller hanging out somewhere on the underlay. So next we attach an access point. That access point is going to connect into a fabric edge node, and we'll build 2 different tunnels off of this access point. The first tunnel is a CAPWAP tunnel to the wireless LAN controller. This is no different than a traditional network in that we're going to send all of our control plane information across the CAPWAP tunnel. However, in a traditional environment, we're also sending the data plane traffic, and we're not going to do that in an SDA environment. Instead, we're going to build a VXLAN tunnel to the fabric edge node to which we're directly attached. So those are the 2 different tunnels. One is for control plane, that's CAPWAP, and one is for the data plane, that would be VXLAN. Last question. An endpoint wants to send traffic to a part of the network that hasn't been integrated into the SDA fabric. Maybe yet, right? We're in the middle of our migration, let's say. What RLOC will the control plane node provide to the ingress tunnel router? Well, anytime we're sending outside the SDA fabric, we need to think about those border nodes. And as we'll recall, we have 2 different types of border nodes. We have an internal border node and an external border node. Now, the external border nodes will connect to the unknown parts of the network. In other words, we tend to think of the internet, especially when it comes to the external border nodes. However, the internal border nodes will connect to other parts of our network that just aren't part of the SDA fabric. That might be intentional. For example, the data center typically isn't integrated into the SDA fabric, and so it might be our data center that we're trying to get to. However, it might just be part of our network that we haven't yet migrated into SDA. Either way, the internal border node is going to handle those connections for us. And so when the ITR reaches out to the control plane node is going to send it the RLOC for the internal border node. And that wraps up this quiz. If you find yourself with any knowledge gaps, then be sure to go back and watch the appropriate videos in order to solidify that. Otherwise, congratulations on completing Explain SD Access Fabric Operation. I hope this has been informative for you, and I'd like to thank you for viewing.